Let's do a tutorial to integrate an equation by parts using both of the techniques. Example number 1. Integrate x times sine x dx. Solution. Integral of x times sine x dx. Use technique number 1 first, where we have integral formula. Write the integral formula, which is integral of u times dv equals to u times v minus integral of v times du. X is the first term and sine x is the second term. Integrate the given equation by parts using the integral formula. We have integral of x times sine x dx equals to x times minus cos x minus integral of minus cos x dx. Our u is x, which is our first term, and dv is our sine x, which is the second term. Now write the x as it is, times integral of second term. Integral of sine x is minus cos x, minus integral of second term and differential of first term. How we got minus cos x dx? Let's do some extra calculation to prove it mathematically. Take the first term, u equals to x. Take derivative on both sides. We have du or dx equals to 1. Separate the x and u variable. Put dx here. We have now du equals to dx. That's how we got du equals to dx. Now take the second term, dv equals to sine x, which is dv or dx equals to sine x. We just took dx under the dv. Now take integration on both sides of this equation. Integration of left hand side is integral of dv or dx. Integration of sine x equals to minus cos x. We know that integration is the opposite process of differentiation. So the symbol of integration will cancel with the symbol of derivative. The derivative symbol is d or dx. These both will cancel each other and we're left only with the v. So v equals to minus cos x. That's how we got v equals to minus cos x. You can skip this extra calculation. It was just to clear your concept and to understand it in a better way. Solve this equation further and we have no integral of x times sine x dx equals to minus x times cos x plus integral of cos x dx. Integral of cos x dx equals to sine x plus arbitrary constant. And this is our final answer for the given equation by using integral formula. Now can we use technique number 2 here? Yes, we can use, because we have a pure algebraic term. Remember, technique number 2 is only applicable if you have at least one algebraic term in your given equation. We have it here, which is x, and the second one is the trigonometric function. It can be any function, it can be exponential. Let's use technique number 2 here. Put differentiation at one side and integration at another side. Take the algebraic term x under the differentiation panel and the second term under the integration panel. Derivative of x is 1 and integration of sine x is minus cos x. Derivative of 1 is 0. Integration of minus cos x is minus sine x. We stop it here because we got 0 at the left side for the algebraic term. We have to stop it here. Put the plus minus, put the extra plus minus symbols. Start from minus, minus, plus, minus, plus, minus, plus, minus, plus, until to the end. Now take cross multiplication. So x times minus cos x is minus x cos x. 1 times minus sine x is plus sine x. Remember, we have 2 minus here. One is the yellow one in front of minus sine x, so minus times minus will be plus, and therefore we have plus sine x. And this is the answer. But if you want to skip this extra calculation, you can skip it. And you can write it in one line. Our first term is x, and our second term is sine x. We will differentiate the first term and we'll integrate the second term. Leave the first term as it is and integrate the second term. Integration of sine x is minus cos x. Now we will differentiate the first, differentiate the x, and we'll integrate the minus x. So minus derivative of x is 1, and integration of minus cos x is minus x. Now we will differentiate 1 and integrate the second, integrate minus sine x. So plus derivative of 1 is 0, and integration of minus sine x is cos x. And we have to stop it here because we got 0 for the derivative term. When you got 0 for the derivative term, you have to stop it. And the symbol goes start from here, minus, plus, minus, plus, minus, plus till to the end. So we have now integral of x times sine x dx equals to minus x times cos x plus sine x. 0 times cos x will be 0 plus arbitrary constant. And this is the final answer for the given equation by using technique number 2.